7.4 example 3. Determine the equation of the function that defines each graph. Write each function in standard form. So our standard form again is ax squared plus bx plus c. So now we're given the graphs. In our example 1 and 2, we were given functions and we needed to sketch the graphs. Now we have the graphs and we need to determine what equations gave us these functions. So we want to look for a few things for our standard form for our answer, but we need to know our vertex, and we're going to use our axis of symmetry and our x-intercepts a little bit here. So on this first graph A, our vertex is at 1 and 2, 4, 6, 8. 1 and 8 is our max value there. We have a y-intercept of 0 and 6. We have x-intercepts of -1 and 0. And 3 and 0. So factored form is we need to first put our equation into factored form, which is y equals some value a, if I'm going to factor something out, and then I have my two values here. We call them p and q, or r and s, or h and k, depends on what your textbook might say, but any value here would go in here. So factored form. So our factors, again, we know that these ones are going to be our x-intercepts. Whatever your x-intercepts are, it's going to be the opposite because our x-intercepts would have made them 0. So y equals a x. So if y of one intercept was -1, then this first factor must have been +1. If my other x-intercept's a +3, then this factor must have been a x minus 3, because my factors, again, are what would have made those terms 0. Now, I don't know if I factored anything out. I might not have, and I don't know what it is. But I do know based on the graph it needs to be negative, as my graph is opening down. So to ever solve for an a value, you pick any other x and y value you know from your graph, and you plug it in for x and y and solve for a. So let's use our vertex. Our vertex y value is an 8. I'm solving for my a, and my x at that point is 1. So 1 plus 1, 1 minus 3. Simplifying, a times 1 plus 1 is 2, times 1 minus 3 is -2. 8 equals 2 times -2 is -4a. Divide by -4 to solve for a. -2 equals a. So we were right, it is a negative value. And we must have had a 2 in there as a common factor, a GCF that we factored out. The question wants us to write it in standard form though. So in our factored form, it's y equals -2, x plus 1, x minus 3. That's factored form, that's not standard form. So we need to use some FOIL and distribution to multiply that all out. So keep your GCF out until last and use FOIL inside. So first terms is x squared, outside -3x, inside x, and last -3. Simplify inside, so x squared minus 2x plus 3, and then distribute your -2 onto what's inside. So -2 times x squared is -2x squared. -2 times -2x is a +4x. -2 times 3 is a -6. So now we have our equation of our graph in standard form. For graph B, now our a value should be positive. It's opening up. It's a little bit wider though than the original, so it might not be at 2 anymore. So we'll have to solve for our a value the exact same way. So first things first, identify some points that you can see obviously, not guessing. So I see an x-intercept here of 2 and 0. And another one of -1 and 0. I don't know exactly what my vertex is. It looks about 1/2 for my x, but I'm not really sure for my y. So I'm going to look at I know my y-intercept is at -1. So 0 and -1 is my y-intercept. So we need to know our zeros for our factored form. So let's start there. Y equals a times x minus r x minus x, or plus. So any of those values. So our zeros go in there. Y equals a. If I have a 0, if -1 made this first term 0, then it must have been x plus 1. If 2 made this second factor 0, then it must have been x subtract 2. So again, that's our factored form, not knowing our a value. So we pick another point that we know, which I said our intercept we know. We can use -1, 0 and -1. So when my y is -1, what's my a if my x is 0? -1 equals a times 0 plus 1 is 1, times -2 is -2, divide by -2. A is positive 1/2. So in standard, or in factored form, y equals positive 1/2 x plus 1 x minus 2. That's our factored form. Again, 1/2 makes sense for our a value. So positive because it's opening up, and if our a value is in between 0 and 1, the wider our function is on our graph. If it's greater than 1, it will become more narrow. So we have a wider graph opening up. We want to factor this out. Distribute, use FOIL, whatever strategy is easier for you, so that we can get it back into standard form. So again, leaving our GCF till the end and using FOIL. X times x is x squared. Outside, inside, last. Simplifying what we had in there, x squared subtract x minus 2, and then applying our GCF onto all 3 of our terms. So y equals 1/2 x squared. Subtract 1/2 x minus 1. There's our standard form equation for that graph. You can always plug those into your graphing calculator to verify too, to ensure that you do get that graph when you plug in that quadratic equation. But we want to make sure we know how to determine the equation from a graph and be able to graph a function from its equation. And example 4. A career and technology class at a high school in BC operates a small t-shirt business out of the school. Over the last few years, the shop has had many sales of 300 t-shirts at a price of $15 per t-shirt. The students have learned that for every $2 increase in price, they will sell 20 fewer t-shirts each month. So every time they increase their price by $2, they sell 20 less shirts. What should they charge for their t-shirts to maximize their monthly revenue? So we want to make the most money. So we know that revenue is going to equal the number of shirts times your price. So let's just write that in word form right now so that we understand that. Number of t-shirts, shirts, if I can spell, times whatever price we decide on. That's how much money we're going to make. So let's let x equal the number of $2 increments. So that means x is going to be the number of times we increase our price by $2. Whether that's going to be a positive or a minus, right? I could increase each time or decrease $2. So back to our revenue question or equation, revenue equals, so the number of t-shirts can be represented by, so we have 300 minus 20 each time we decide to go up or down by $2. That's how it's affected. And then our price is a set 15, plus we're going to be adding on $2 however many times we decide to do that. So that's why our x is the number of $2 changes that we make, not the amount of money we make when we increase or not. We're just letting that be the number of times we make that $2 change. So this first bracket is in terms of our number of shirts. So always have 300, but then we lose 20 for every time we decide to go up or down by 2. And our price is $15 set plus an extra $2 when we increase it times X amount of times that we choose to do that. So this is in our factored form right now. We have two factors, two things multiplied by each other. So we can easily graph this by just changing our R to a Y. I would use your graphing calculator for this one. So if we pull that up and we graph that in brackets, 300 minus 20x bracket 15 plus 2x, and graph what that looks like. Can't really see much, so we need to change our window for sure. One thing that's helpful is if you were to expand this using FOIL, your last constant, so the one that doesn't have a variable, is always your y-intercept, and then you would know how high up for sure you need to go. So that's going to be 300 times 15. Those two things multiplied by each other will never have an x, so 300 times 15 is 4,500. So let's try 5,000 right now. Oops, that should be with my y. X minimum would be 0. Again, I can't have a negative increase or decrease. Y is going to be how much I make, so let's leave that at 0. So my Y max is what I had said. Let's try that to be 5,000. And an X max, let's just try 10 right now, because that's the number of increases. We might not increase 10 times. So let's try this to see what we can see. So it's better. We want to show more Y values. Let's go higher up. So let's say 6,000 instead of 5,000. Okay, and we're not quite seeing all of our X's either. So let's make our X max maybe 20. Much better. So now we can see what the graph actually looks like up here. And the question was asking, what should they charge for their t-shirts to maximize their monthly revenue? So what's our X value when our Y value is the highest? So let's find our max value here, which will be our vertex. So calculate our max value. So we need to go to the left of our highest point. Anywhere over here, yes, we're left. Now we go to the right side of that point and guess. So it says our max point is when my X is 3.74. I'm going to make $5,062.50. So in order to find what price do I have to charge, well, my X value is 3.75 increases of $2. So that's how many times I'm going to go up by $2. So it'd be 3.75, so not even quite 4 times. So we want to plug that into what price would I charge, and that is our second bracket here. That's 15 plus 2x. So my price is 15 plus 2x. And if we said we made the most money when our x was 3.75, then we want to do the math there. So 15 plus 7.5 will give us $22.50. If I sell the shirts for $22.50, I'm going to make the most money before I start to lose too many shirts. That's my highest point. My revenue is at its highest point. My highest point of $5,062.50. If I increased my selling price of $2 3.75 times, I'll sell my shirts for $22.50 and I'll make the most money. So that has answered our question. Now your assignments on page 391. Number 2, 3, 8, 9, 10, ACE 11, and 16. Please make sure you're doing these, as these are going to start to get a little trickier when you're getting to solve application questions like the one above. So make sure you're getting all of your practice in before you attempt any hand-done assignments. Come see me for questions when you need.